Alright, I'm going to be working on the Intro to Logs worksheet, which is just getting us an idea of what in the world does a log mean. Okay, we deal with single letters and numbers in the math world, usually 3 of them at a time. So a log is just a way of, in a way it's just rewriting an exponent or an exponential. And so what it means is, for the number 1, log base 2 of 4, that's how you'd read it, log base 2 of 4. It's saying, what power do I raise a 2 to get 4? So these have the same meaning. Log base 2 of 4 equals what? Alright, so what it's asking is, what power do I raise 2 to get to 4? And the answer, I hope you know, is 2. Okay? And that's why we can do this without a calculator. So if you put that into your calculator, let me show you how to do that real quick. So if you put that into your calculator, you're going to do math, then you hit alpha and math, or another way that you could do it would be to hit math, and if you go up to, see where it says log base, and hit enter. Well, it doesn't want to do that for me. So if we put in log base 2 of 2, oh man, just really got me. It's log base 2 of 4, it's going to give us 2. Alright, number 3, just looking at the odds here. What does log base 6 of 36 mean? It means, what power do I raise this 6 to? 6 to what power equals 36? Okay. And so if we have this written 6 to the x equals 36, you know, okay, yeah, so x is going to be equal to 2. Okay, or, so log base 6 of 36 is 2. The answer to a log is the exponent. That's what it's going to tell you. It's going to tell you what, if the base is 6, I raise it to the second power, and I get 36. Okay, so on a lot of these that we're starting you with, the actual answering of the question is not super difficult, but as we go, you'll definitely see, I think, why they become so valuable. All right, next we got log base 4 of 16. So that's saying, what power do I raise 4 to get 16? Surprise, surprise, the answer is 2. But what if I had something like log base 4 of 64? What does that equal? So 4 to what power equals 64? We know 4 to the second power is 16. If I multiply that by 4 again, I'm going to get 64. So the answer to that would be 3. So as the answer to these gets larger and larger, that number, which we call the argument, 64, gets really big. All right, so now we're going to go backwards. We're going to look at logs, or using logs to take things out of the exponent. That's what they're really good at. So if you have 11 to the k power equals 71, a way that you can do this is to say, basically take the log of both sides. And this is the power property for logs. So when you take a log of a base 11 raised to the k comes out front, the log remains, you have log of 71. Now divide by log of 11 on both sides, and you get k equals log 71 over log of 11. All right, real quick, we're going to talk about what does this mean and how can we simplify it a little bit. So what this means is log base 10. So what power do I raise 10 to? All right, if you just see a log with no base, it's a 10. So 10 to what power equals 71? That's going to be a number less than 2. Divided by log to what power equals 11, or 10 to what power equals 11. So that's going to be a little bit more than 1. And you're going to divide those and you'll find out what k is. Okay? That sounds like a big mess, but let's kind of compare this to what we see in number 5, where we're going back and forth between forms. So I'm going to clear this real quick. So what this means is 11 to what power equals 71? So the base on a log would be 11. say 11, we're going to raise it to some power that we don't know yet. And what do we get? 71. The way I say it sometimes is that the base, 11, stays the base, and the other two kind of trade places. And the exponent is gone now because we've changed it into logarithmic form. So another way you could write this is that k is equal to the log base 11 of 71. Okay? And then I'm going to show you one more way to look at this, but I think it's helpful. So log, or 11 to the k is equal to 71. I just really want to use log. Okay, so we taught you another property, this little identity, that if you take the log base 11, or so if the log, or the argument and the base are the same, 11 and 11, and what is that equal to? It's equal to 1. It's still going to pull the k out of the exponent, so you're going to have k times log base 11 of 11, but log base 11 of 11, that's just 1. So all that's left over here is k. But if I take the log base 11 on the left, I have to take log base 11 on the right. So here I get k is log base 11 of 71. Okay? So a lot of ways to do this. If you do it either of these ways, you'll end up with the same thing. So this is more about understanding what is a log, what is it, what does it mean, and how can I rewrite an exponential in logarithmic form. And the numbers, or the one on the right over here, is a way to answer number 7 that's more like we're used to with algebra, where we do the same thing to both sides, and it helps us find the variable. So there's 1 through 7. I'll stop right there and then jump back in with a new video.